Hello, welcome to Astronautics for Exploits. This is Dr. Anshola Ogundele. Lunar Space Gas Station, a driver of interplanetary space exploration and actualization of human space settlement. The focus points are as follows: lunar missions, Lunar Space Gas Station, rationale behind Lunar Space Gas Station, and Lunar Space Gas Station Company. For many centuries, based on the priceless natural wonders and abundant resources it encapsulated, Moon has been an object of interest to the humanity, and as a result, various lunar missions have been undertaken and are being planned to unravel the mysteries abound on the Moon. Various government space agencies and private space companies are investing in technologies that will help humanity to push forward the Moon exploration. The commencement of lunar exploration is dated back to the 1950s. Lunar 1, the first spacecraft to fly by the Moon, was launched in 1959, followed by the Lunar 9, which achieved first soft landing in 1966. Afterward, various lunar landers and orbital missions have been developed and launched to the Moon. For many years, efforts have been made to develop lunar gas stations in lunar orbit or on the lunar surface. This is to aid exploration of this space. Research findings show that refueling near the Moon will allow for humans to get to Mars much more efficiently than launching from Earth with all the resources on board. Various companies are planning, researching, and investing in the establishment of lunar fueling stations. The lunar fueling stations are to be used for refueling spacecraft and to support people that will be living in space within the next 30 years. Examples of lunar space gas station companies are Lockheed Martin, Boeing, Sislon, Shaku Energy Company, the Moon Express, and a host of others. Lunar missions. Presently, all space missions are based on and launched from the Earth. Because of the high Earth's gravitational pull, to get into orbit, a rocket has to be traveling about 11 kilometers a second, that is 25,000 miles per hour. Any rocket leaving Earth must carry all the fuel it will use to get to its destination, and if needed, back again. The fuel is heavy, and getting it moving at high speeds takes a lot of energy. If it could refuel in orbit, that launch energy could lift more people or cargo or scientific equipment into orbit. Rendering of a lunar base camp is shown in this picture. NASA's Lunar Reconnaissance Orbiter and Lunar Crater Observation and Sensing Satellite missions found substantial amounts of ice in permanently saddled craters on the Moon. Those locations will be tricky to mine because they are colder and offer no sunlight to power roving vehicles. But the proposition is to install big mirrors on the craters' rims to illuminate solar panels in the permanently saddled regions. Illustration of lunar orbit station is shown in this picture. Depending on where the best ice reserves are, the space company's plans are to build several small robotic moon bases. Each one will mine ice, manufacture liquid propellant, and transfer it to present spacecraft. One proposal to accomplish the developed plans is to develop 3 different types of rovers. It also involves building small robotic shuttles to meet up with nearby deep space mission vehicles in lunar orbit. Illustration of lunar gateway in moon orbit is shown in this picture. First rover, the prospector, will explore the moon and find ice-bearing locations. A second rover, the constructor, will allow behind building a launch pad and packing down roadways to ease movements for the third rover type, the miners, which collect the ice and deliver it to nearby storage tanks and an electrolysis processing plant that splits water into hydrogen and oxygen. Illustration of the concept of a lunar base is shown in this picture. The constructor will also build a landing pad where the small near-moon transport spacecraft, referred to as lunar resupply shuttles, will arrive to collect fuel for delivery as newly launched spacecraft pass by the moon. The shuttles will burn moon-made fuel and will have advanced guidance and navigation systems to travel between lunar bases and the target spacecraft. An artist rendering of a fuel depot for refueling deep space mission is shown in this picture. When enough fuel is produced and the shuttle delivery system is tested and reliable, the plan is to build a gas station in space. The shuttles will deliver ice directly to the orbiting fuel depot, where it will be processed into fuel, and where rockets heading to Mars or elsewhere go back to top up. The depot will have large solar arrays powering an electrolysis module. An artist rendering of a solar electric propulsion thug above an asteroid is shown in this picture. Lunar Space Gas Station. Over the years, efforts have been made to develop lunar gas station in lunar orbit or on the lunar surface. This is to aid exploration of this space. At the moon, there's low gravity, and as a result, there's no need for much thrust to go from the moon to Mars or another asteroid. Illustration of the concept of the world's first geostationary propellant depot around the moon is shown in this picture. Research findings show that refueling near the moon will allow for humans to get to Mars much more efficiently than launching from Earth with all of the resources on board. Generating power on the moon is an important strategy that government space agencies and private space companies are investing in. Illustration of orbit fire refueling working principle is shown in this picture. The moon is envisaged to become a gas station that will allow rockets to refuel for their return to the Earth or fill up for their onward journey to Mars. The moon has no atmosphere, but oxygen is available if the lunar soil is heated to extremely high temperatures, and that requires power. There are no fossil fuels on the moon, and there are no wind, way for hydropower options. As a result, space agencies and companies are investigating establishment of lunar gas stations. Illustration of astroscale in-space refueling services is shown in this picture. Rationale behind lunar space station, gas station. Lunar gas station, either on the lunar surface or orbiting the moon, is an important requirement for the long-term future of human interplanetary exploration. For missions to Mars, spacecraft will make pit stops at fueling stations, orbiting the Earth or Moon to fill their tanks with liquid hydrogen and liquid oxygen generated in space. Rendering of a lunar base camp is shown in this picture. Hydrogen and oxygen must be kept very cold, minus 253 degrees Celsius and minus 183 degrees Celsius, respectively, in order to remain in their liquid state. While space is cold, the sun is a powerful source of radiant heat, so any space-based gas station will have to be insulated and have solar-powered coolers to maintain the ultra-low temperatures. Artist's impression of think orbital platform for in-orbit fuel depot is shown in this picture. Lunar Space Gas Station Company. Various companies are planning, researching, and investing in the establishment of lunar fueling stations, and they are to be used for refueling spacecraft and to support people that will be living in space within the next 30 years. Examples of lunar space gas station companies are Lockheed Martin, Boeing, Sisloon, Secutin Energy Company, the Moon Express, and a host of others. The Orbit General Expansion Architecture spacecraft designed for in-orbit servicing of satellites is shown in this picture. The site of the projected fuel station is the Moon's South Pole, where water, ice, and hydrogen were found to be relatively in greater supply. The site findings show the presence of 1 billion tons of water ice are preserved in permanently shaded crater slopes facing the South Pole, with another 600 million tons estimated for the North Pole. SpaceX Starship refueling proposed approach is shown in this picture. Shakutin Energy Company is another lunar space gas station company. It plans to split lunar ice into its hydrogen and oxygen components and sell them as liquid rocket fuel to customers interested in sending spacecraft to the low Earth orbit. It is assumed that the cost of fuel from the gas station on the moon will be much less than the propellant carried from the Earth. Circuiting Energy Company Lunar Base and Space Gas Stations concept is shown in this picture. The Moon Express is another lunar space gas station company, a company with lunar ambitions and visions, using lunar ice to produce high-performance hydrogen peroxide fuel, both to sell to spacecraft operators and to power its own mining operations on the Moon. Hydrogen peroxide is a molecule made of two hydrogen and two oxygen atoms, which is rendered highly reactive with catalyzers. Artist's concept of a robot servicer using propellant transfer technology to extend the life of orbiting satellites is shown in this picture. Loon, a technology lab working to accelerate the timeline of placing humanity back on the Moon, has been selected by NASA to develop core technologies for lunar space gas station to power the future of space exploration by producing and supplying crucial lunar-derived propellants. It is planning to develop infrastructure to extract water from the permanently siloed craters on the lunar surface. Sample rendering of Loon tech extracting lunar resources to produce rocket propellant is shown in this picture. For more information, contact Astronautic for exploits. You've been listening to Lunar Space Gas Station, a driver of interplanetary space exploration and actualization of human space settlement, presented by Dr. Anishola Ogundele, with the focus point Lunar Missions, Lunar Space Gas Station, reasoning behind Lunar Space Gas Station, and Lunar Space Gas Station Company. Thank you.